Hi guys, welcome back to my channel. We did our updates. In our last video, we had just looked into how the different kind of metadata files are formed when we create a table or when we insert values into that particular table. Right? We just looked at how to create that table, how to insert values into that table using Iceberg basically, right? And then I promised you that in the next video we'll just look into the metadata files that are formed behind the scenes because it's also important. Because in the upcoming video, I'm gonna explain you people how to use those metadata files basically in order to navigate your production issues in the most easiest way in order to optimize your backend data set, right? So there are multiple production use cases that we have that we and for those use cases we'll make use of the metadata tables basically, and those metadata tables basically contains information related to these metadata files. So first we need to understand um, about these metadata files, right? Now the first thing, what did you know? We knew that, let me just show you the architecture. Okay. Yep. So in one of the videos I had explained you about the architecture of Apache Iceberg, right? Now what did that architecture basically have? Basically, if you look on the screen, let me just take up the laser pointer. At the granular most level is the data files, right? Now the information of these data files is basically stored in the manifest files, right? But the information about these manifest files are stored in this manifest list. And information about this manifest list is basically stored in the metadata files. Now, what kind of information does manifest list store with respect to the metadata files? The manifest list basically consists of the information related to the latest snapshot. All right. Now, if you see over here, we had our version 0, and then we have our version 1, right? So if you look at this manifest list, it consists of version 1 information, right? So, so version 0 information is stored in this particular manifest list. So basically, if you understand, a particular manifest list basically points to a particular version which the metadata file stores. So version 1 has got a particular manifest list, then version 2 has got a particular manifest list, then version 3, and so on, right? So that's basically the overall crux of the architecture, right? Now let me just get into this the screen, right? So when we inserted values into the table, what extra metadata files were formed apart from the v1.metadata.json file and version hint.txt file, which were formed when we just create the tables. Those files were basically the manifest list and the manifest file. So manifest list is basically this one, right? And manifest files are, no, sorry, the opposite way. Manifest list is basically this one, snap dash. It consists of snap dash, okay? And the manifest files are basically this one, right? Both of these have got the Avro file format, but snap is present in the snap dash basically is present in the manifest list, and in the manifest files it does not have any snap dash, right? Now let me just explore the manifest list, all right? But no, let us go the bottom to top approach. First let us explore the manifest. First let us explore the data files, and then the manifest files, and then the manifest list. But I think the most appropriate to explore would be the manifest file because it consists information of the about the data files even, all right? So when you look, I've just run a query to read the Parquet the Avro file format. All right, and in this one, I'm reading the manifest file path. Okay, so when I just read the manifest file path, I see there are three records which are present. Okay, all of them have got a same snapshot ID. That means all of these records or all of these data files basically consist are basically belong to the same snapshot ID. All right. Now, since all of these data files belong to the same snapshot ID, let us just explore that what is stored in each of these data files. Each of these data files is basically different. That's for three different data files. All right. Now, the first data file is basically business unit equal to technology. That's what we can directly infer from this. Get partitioned upon business unit, And we had three records that were inserted into the table. What were these values? One, engineering technology, two, marketing sales, and three, sales seats, right? So the first data file is with respect to technology. So that's what we can infer. We can basically infer that the data files are basically formed with respect to a partition, right? The first information, that's what we have got. Okay, now see, I'm just going to read this particular um, data file, all right? And when I read this particular data file, let me just paste over here and let me just run it. Till then, we can see on the screen that the file format of this data file is basically Parquet, okay? And it's basically partition upon business unit, right? That's what you can see over here, business unit technology. Yeah. So what you can see on the screen, it consists of the first record that we had inserted in the table. It's one engineering technology, right? All right. So now that's the first information that we have inferred from this particular record in the manifest file. Okay. Now next thing, what is the file size of in bytes of this particular data file? It's basically only 1064. Okay, it's 1064 only. All right, but the block size in byte, it's written 67108864. What does it mean basically? So one thing notice over here, what we have seen that the block size in bytes is 67108864. What does it mean basically? We need to see that. The second record of the manifest list also in and manifest file also, you can see it's basically same. It's the same value, 67108864. And also in the third record of the manifest file, you can also see it's 67108864. What does it mean? If you think logically, this is basically the default block size. What do I mean by default block size? It means that in a particular row group of a Parquet file, it's the default volume of data that can be stored. If you convert this 667 something to this, stands around 66 or 67 MB. All right, it's the default block size of the Parquet file when you partition. Okay, but since you have only since you're partitioning upon business unit, and since you have only one value, only 1064 bytes of data is stored in this. So out, this is the default block size. Okay, and within that block basically you have only this much bytes of data that's being stored. So maybe you can understand that this is a small file issue, right? Because we have very less data stored. Okay, we'll understand about this maybe in our next video. Okay, now, and of course after understanding these files only we'll be able to optimize these files. Okay, now the next thing, column sizes. What does column sizes mean? Now over here you can see 0 1 2, and each of these has its own value. Okay, 0 1 and 2, and we know from this that it's something with respect to columns, sizes of the columns. Okay, now, key 1, key 2, and key 3 basically denote something unique. What unique? That the it's the ID of that particular column. Okay, so ID 1 has only 47 bytes of data. So column 1 has only 47 bytes of data. ID 2 has only 58 bytes of data. So column 2 has only 58 bytes of data. And ID 3 or key 3 has only 57 bytes of data. Now key 1, key 2, key 3, what does it denote? Let us just see. When we go down and look into the metadata files, which I've read over here, just go down, COV. ID1 basically denotes you have the fields over here, then you have the ID1 over here, and then within that you can see you have the name over here, right? One second, stay in the call. Yeah, let us just continue. Okay, this has ID1. Okay, and ID1 means name is department ID. All right. Then when you go down, you have ID2. ID2 has name as department name, and ID3 is basically the business unit. That means each of these columns, department ID, department name, and then you have the business unit, has got its own ID. Okay, so column ID. So basically, what you see over here, yeah, so it basically denotes a basic unique ID, and each of these column IDs has its own data volume, 47 bytes, 58 bytes, and 57 bytes. All right. Now, what does value count mean? Value count means basically the number of values that is stored within that particular column. Okay, value is one. So, what does value count mean with respect to this particular data file? Now, this data file has got a single value only, right? If you export this data file, only a single value is there, one, right? Only one value is there. So, department ID as column ID as one. So, column ID one has only one distinct value. Column ID 2 department name has only one distinct value. Column ID 3 business unit has only one value, right? So each of these, so basically don't get confused. It's not the distinct values, or it's basically the values with it, with which number of values which that particular column has. So each of these columns has only one single value. So that's why 1, 1, 1. All right, value comes. Then null value comes. Similar, we don't have any null value in each of these columns, right? And so each of these columns has got zero null values. So the value has been allocated as zero, right? Then NaN value comes. We don't have any NaN values over here, right? Then the next thing that's very interesting to understand is the lower bound and upper bound. So, what is the lower bound and upper bound? See, all of the information that you see in this particular row basically is with respect to one data file itself. It's not with respect to multiple data files. So, what we can understand that this manifest file has information with respect to each of the data files in the backend, right? So information of the lower bound and upper bound of each data file, information of the value count of each data file, information about the maybe block size of file size of each data file, information of the partition of each data file, all of those things. Okay, path of each data file, right? Obviously the path, right? So null value count of each data file, all right, and within that each data file, each column information. So column wise information of each data file basically. So practically you have now understood that manifest files basically consist of information of each column within the data file, within each data file basically, right? Now within that particular data file, what is the lower bound? You see, if you look at over here, column ID 1 has lower bound as this one. Lower bound means the lowest value and upper bound means the highest value, right? So column ID 1 has lower bound as this one. Column ID 2. So department ID has the lower bound as this. See, this entire data file is basically a single record, right? One engineering and technology. So logically, if you think the lower bound of department ID and the upper bound of department ID is same, it should be one. Similarly, the lower bound of department and the upper bound of department name is also same. It's engineering. Similarly, the business unit has got the same lower bound and upper bound because only one value is there. Correct? So what kind of values are this? Obviously, if you look at a way, it's one, but what's written over is something different. If you look at this, it's something and some kind of encoding there is there, right? It's not some kind, it's basically the base 64 encoding that's taking place behind the scenes. All right. In the similar manner, we also have the upper bounds of that particular column ID. It's all same. That's what I have told because we have only a single value within that data file. So I column ID 2 has got this value. Column ID 3 has got this value. Now let us try to just decode this and understand that are we actually correct in saying that these are basically the base 64 encoding of the lower bound and upper bound? Let's just look at it, right? I don't know whether the integer values decoding will able to understand. Okay, let us just put it in place and understand. Base 64 decoding that we are doing. It was the encoding that was done. Now we are decoding it. Okay. Okay. Right. See, we are not able to decode. If you decode over here like this, are we able to do it? No. So integer byte has a wrong byte ending unit. Okay. All right. As integer maybe, can we do it like this? And is it running? No, 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 no. Okay, it cannot cast binary as int. What is it? Let us basically see. No casting. Let us just remove the casting and then see. are we getting something very interesting out of this? Just let us decode it. Okay, wrong 4 byte integer encoding, and if we do equal to, what is happening? Equal to is decoding as a. Okay, let me just do this. Mhm, mhm. Equal to, will it work this time? No, it does not work. Okay, is it working? No, no. Just leave it. Okay. So when we try to do this one, it's basically we are not able to decode. Let us try with a different value. Alright. Let us take up this value. Are we able to decode the lower bound of column 2, column ID 2? Basically which one? The department name. It should be engineering if you decode it, because we have understood that both the upper bound and the lower bound is same. Let us just put it in place, and we have a string over here. Now let us see. I probably think we'll able to do it. Yeah, we have done it, right? That's basically engineering. So it's basically the base 64 encoding that's being done behind the scenes in order to store the lower bound and upper bound. How does it help? It basically helps us in partition pruning, right? It helps us in the amount of data that needs to be scanned, because we know that within that each data file which the manifest list has, okay, we know it's lower bound and upper bound, and using the lower bound and upper bound information we'll be able to track down the value which needs to be brought in the shortest possible time. Okay, so if we search that where department name, okay, equal to engineering, it will not scan across all the files, it will scan across the first data file, and in the first data file what it will scan, that it's up to the query engine, right? It will be able to scan according to this lower bound and upper bound values. Suppose if the lower bound was engineering, the upper bound was maybe sales, then it will scan within this particular data file itself, which has engineering and sales as its lower bound and upper bound, nothing else. Okay, similarly if you take the column id 3. Okay, we'll just look into how this lower bound and upper bound will help us in scanning lesser number of files while retrieving data. That's what we'll explore. But prior to that, that's what we're exploring right now. Just run. Let us run this one. You see, it's technology, right? So business unit is technology. So column ID 3 has value technology as the lower bound, and when you go down in the upper bound, what you can see, it's also the same. So if you just decode it, because it's important, it's always giving the same value. So the lower bound is upper bound is same, just as we had logically thought about it, right? Now what you can see, we have the split offsets. What does split offset basically mean? So just try to understand that when you have a particular data file, it's being further broken down into several chunks, right? It's the concept of big data. Now you have a single data file. Now you break down into multiple parts. Okay, so from where, so chunk one will be from a certain zeroth or first bit to the fourth bit. Chunk two will be from fifth to maybe hundredth. Okay, chunk three will be from hundredth to maybe 200th. So this split offset basically helps us identify from which part to read the data. Now since only a single data file is present, we are reading till the fourth. Okay, so it split offsets 4. Similarly, if you look at the data file 2 or the record 2 of the manifest file, there's a different data file. And what is the data file? It's basically business unit equal sales. We'll just fastly go through this, because we again have to understand the manifest files. Okay, let me just run this one. And you see department id 2 marketing sales. So because basically it's with respect to the second record that we inserted. And similarly this has the file size is basically 105 bytes, the block size is basically the default block size that we have. And then we have the column sizes, that column id 1 has size as 47 bytes, column id 2 has size as 56 bytes, and then column id 3 has size as 52 bytes. Similarly, we have got the value counts, that how many values are getting stored in that particular column, ID and how many null values are there, which is actually none, which, so that's why 0. And then the lower bound and upper bound, which is actually being same, because okay, sorry, which is actually being same because we have got the same value, we have got a single value in that particular data file, so the lower bound and upper bound is always the same, right? So that's the kind of information that we are getting up.